So, another video of me programming in BQN. This time I'm gonna work on Snake2 because Snake2 is very nostalgic to me. If you don't know which game I mean, it's this one on the old Nokia. It's this cool snake. It's like the more advanced version of Snake 1, which was just simple blocks. And it has awesome graphics. And I was really drawn into the nostalgia, but also the graphics. Where you actually see like details of the snake. Here's a better video. So as you can see, the snake has quite a lot of cool detail. It has like a body and a head and its mouth opens. And I really wanted to recreate that. And I'm gonna do that here live. I already programmed it, but I got really stuck with figuring out the way the graphics were drawn, because first I thought I needed to draw these little things and then of 4 width and a 4 in the height because there's space around them. But then I got stuck in the corners because these corner pieces, they look like triangles, and they're not always triangles. There are sometimes, like here they're both triangles, but other times one of them is, for example, here none of them are. And I was really stuck with, like, how does this work? How do they differentiate between the angles and triangles? And I found an algorithm to do it. But then I saw that if he turns a corner, he aligns differently. But then I really looked at it again, and I saw, no, I should think of it like this. This is a square, where it's off, on, off. And this is just a full square. And each step, when I move it step by step, it just moves 2 blocks. And I was really stuck in this and I couldn't figure it out, but I thought, like, let's just start the video, program the basics, and then find out live how this works. Because I thought I just want to make this video and I have other stuff which constantly comes in the way. And I just wanted to put down some content. So let's jump into it. This is the BQN, Ray-lib environment again. I'm using the BQN programming language, which is an array language. It's awesome, look it up. And I'm using Ray-lib, which is an awesome game engine, and specifically the hook, I think it's called, for BQN, the BQN hook in Ray-lib. Okay. I'm gonna make file snake to BQN, and I already made that, so let's call it live. And I'll make the code bigger with this awesome new feature. Whee! I'm here. I'm gonna put myself in the corner somewhere. Okay. I have some old code here to cheat, to see what I'm doing. So I'm just gonna copy again all the imports I'm gonna need. These are sort of become like the default. You want color, window, font, draw, mouse, key, math, and RayFFI. And you want the standard boilerplate, so this unstart stuff, and defining a game, which is a while loop and a start function, and then I'm calling that with some parameters. So let's write that on start function. A bit of spoilers, I'm gonna quickly remove all this. So a game, or the game object which I passed in, which is the per frame function. It's a bit confusing actually, but yeah, that's what it is now. And a per frame function, which is gonna be the main loop. Let's delete that for now, delete that for now, delete these for now. And as you can see, this background color is a bit different. That's because I'm trying to imitate this color. I literally picked it from the screen because that's like part of the nostalgia. Ideally, I'd also have the pixels aren't perfectly full. They don't align perfectly. That's a lovely detail. And also there's a shadowing. Like there's another version of the pixels as a shadow underneath. Also very cool to recreate to get that effect. And also maybe the scratches on top, but those are all details for when everything works. This doesn't run because I'm not doing anything. Yeah. Okay, that runs, and again, it's running on the left screen, so I'm gonna need to copy from the asteroids game in the onStart this stuff, which positions it to my main screen. Yes, so there you go. Here's the game screen. Yeah. So we're going to start with defining. Let's first maybe define the grid, because Snake games are famous for working on grids. And we need to set some definitions for what this grid is. I wrote it last time. I divided it into two parts. One is the screen, which defines things for the literal window which is drawn. Maybe I should call it window. That's, I think, a bit better. The resolution of the window you can define here. I looked up the resolution for the phone screen, and that one is 9.6 by 6.5. Only, as you can see on the phone screen, the top parts are taken by this score counter and some space. And I think I did a rough estimation that those take up 10 pixels. So we subtract 10, and then we get the playground pixel size. And then we don't want to draw it this small, because modern screens are very high density and then the game becomes very small. So we want to use a scale. I also want to export this, which I used 8 last time, but probably I need a smaller one because the resolution is set to low now. To scale it up so you can see everything better. Okay, and then we have the playground, which was the name I gave for the field the actual snake is moving in. The playground has nodes. I call it nodes, which is where how many pixels a single part of the snake takes up. First I thought it was 4x4, which was this whole thing and some space around it. But now I think it's 2x2. It's these 2 pixels and these 2 pixels. And there are just empty nodes around it. Because, yeah. So I'm going to do 2x2 node size, I'll call it 2x2. And let's also define the size of the player grid. So that's the resolution of the screen divided by the node size, because each cell has a size of 2x2, so you get a smaller playground size than the whole thing. Yeah. So screen or window now dot resolution divided by node size, and to be sure we want to floor it, so it's always whole values. And I don't think I need to use that actually. Okay, so we can set the resolution of the screen to that resolution. Last time I used this whole thing. Oh yeah, you can use set window size. I don't need that. Set window size to the window scale multiplied by the window resolution. So that's just these 2 things, which means we're going to get the scaled up version of the screen, which is going to look like, oh yeah, I'm now using window. That looks like this. So this is a small version of this screen. I hope. Now I'm scaling it. That's the idea. Doesn't really matter if it's not perfect, but we now have a grid of 2x2 elements, which you can move the snake in. Okay, and again we want the player class. I call the player class snake. And this is going to be a class which is going to get called and it's going to return some stuff. Actually, I want to try to not use classes anymore, but use functional programming, which is this function is only going to return the data needed for Snake. And then I have some functions which I can call, which is going to modify the Snake. That's different from having an object, which you get an instance from and then call functions on. Because if you create a class or do object-oriented programming, you get a lot of modification within the class. And I found it very hard to deal with cases where, for example, the snake has some information like the head is at a candy, and I call them candies, the thing that he eats. And then you need to delete the candy, like fill the stomach of the snake. And there's lots of stuff and different things, and I think that's very messy. So we just want to do all the control stuff, all the modifying in one place, and only have this as a collection of functions which can deal with the things the snake needs to do, if that makes sense. So I'm gonna create a get function. Okay. Create a get function which will give us the snake. I guess we could give it some parameters like the position or the length. I'll give it the length just to make it feel more like a function, I guess. So the snake is just going to be an array of positions, very simple. The first one of which we can just start it in the corner, which is 0, 0. Let's make it this. Or I like to do higher dimension arrays. So the X line, the horizontal line, I don't know the correct terms. They're still a bit hard for me to understand. But the horizontal lines are just going to be the X and Y, and the vertical lines are going to be all the other positions. So 0, 0, 1, 0, and 2, 0, 2, 0. And if I check that, run it here, you can see it's a two-dimensional array with all these positions. That's enough, I think. We need to be able to draw it. Draw. Yeah. So we're gonna get the body. I'll call this the body of the snake, which includes the head. And for now, we're just gonna draw the grid blocks, just as full blocks, and we're gonna do the details later. So we want to go over each part of the body. We want to go to d.rectangle function with c.black. So draw a black rectangle for over the cells of the body, which are the positions. Let's check the rectangle function again. So you want the xy 1. So xy of the 1 position, xy of 2 position, which means we want the left and the right positions and the color. So then again, we need to calculate with the size and with the position the two things. And we already did that last time. And we do that by, on one side, giving the, let's first wrap this in a function. And this goes over the cells. So now x, the x parameter, this one, is a piece of the body, so a position. Let's see, we take x, which is or on the left, which is a position, and we take the size, which is a node size, multiplied by the window.scale. Yeah, because then we scale it up as well. And then what we do is subtract and add, and then compose those, like that. So we have the subtracted version, the added version, and that should draw the rectangle. Okay, so let's create this, let's get this snake. Our snake is snake.get. Yeah, and we had a parameter, we don't really use it now, so you can keep it like this. Pass in the snake and receive it here, and then call snake.draw. And so these are interchangeable. more of an aesthetic thing, and pass in a snake again. That should, oh wait, yeah, draw doesn't work like that anymore. We want to pass in a snake to draw, which is gonna draw the snake. Okay, doesn't work. Dot must precede a subject. Snake.get. Oh yeah, I'm using a capital version. We don't want that. This doesn't need to be a function anymore. It can just be a collection of functions. Unidentified identifier. Node size. I'm using node size without referencing where it is. That's in playground. And snake.draw, trying to reach a field from non-namespace. Sorry, this is a bit messy. 27 draw snake. Ah yeah, now I'm taking up the word snake. So let's call it snake f. Very random, it's just, I guess, snake functions. Just have some differentiation. Okay, there you go. Here's the body drawn in 1 pixel. Don't know if it's correct. But to see if it's correct, I guess we're gonna start moving the guy or gal, snake. Let's make a move function. Okay, we're gonna receive the body. What we want to do is move it in the direction the snake is looking. So the snake should have a direction. So I guess we can't use the only return the body. We need to also return a direction, which is going to be 1, 0 first, so to the right. Combined with that. If you run it, it adds it there. Don't want that in a list. That works. So first element now is the direction, the second is the body. Okay, so we pass in the snake in draw, or actually we now want to select the second item. That returns second item, right? Yeah. So next to this direction and position, we want to have a way to know which one is which. So let's define a structure, I guess I call it, which is just a list of variables which have the index of the parts of the snake you want to access. So first is the direction, and then is the body, and we're going to export that as a range of 2, which means that this is going to be an object with 1 and 2 in it. With that. So it's just a list of 1 and 2, and you can call them by their names. Struct. Let's call it struct, just to be a bit shorter. So here you. So if you're drawing the snake, you're gonna index into the snake at snake f dot struct dot body, which seems a bit long now that I'm typing it, but it should work. It does. Okay, back to the move function. So we have the body and we have the direction. We can decompose this as direction and body. What you want to do is take the body, shift it forward. This means remove the last element. Yeah, remove the last element, major cells of X. Okay, so we remove the last element of this and we replace it with this new element. And the last element is that one. I guess the snake is the wrong way around. We want to rotate this so that the last element is the first element. We're removing the last element and filling it with a new one. The new one is the head, which is just the first element of the body. On which we add the direction. So that should move it along. Let's do it. Snake F. Oh wait. Snake, and then we do this function dot move, and we pass in the snake. That should work. And it doesn't. Let's see what's wrong. Or it doesn't like me picking the second element because what it returns is a list. That's what I'm guessing. Like you can see here, it's not happy that it returns a 3x2 list, I guess, if I'm understanding it correctly. Probably not. But it works when I'm picking over major cells. Only you get an encapsulated version. So what I'm doing now is picking the major cell, destructing it, or what is it called? Merging it, taking away the outer structure, and then it works. So I wish I knew why, but this is how I'm doing it now. A lot of stuff happened. All I'm just doing is modifying the function so you can call them like this. And all the logic of unpacking and repacking the snake happens in these functions, which I think is a bit neater. Okay, so we have a snake going over the window and we want to be able to control it. So let's make a orient function again. A lovely orient function, which is going to give us, we're going to give the snake again. And all we need is the direction, of course. So let's unpack the snake again into direction and body. Just for easiness sake, let's create a unpack function, which is going to give us a list with the direction and the body from the snake. So it's going to return this interface, which is the unpacked part of the snake. And then we can access that. So we have easier control. So for example, we can remove this with unpack snake. And then you see, let's call it u. And then we can just access these with u.dir and u.dir and u.body. So we have unpacked versions. That works. Okay, so we want to orient snake. Let's get an unpacked version again. Unpack snake, where we have the we have the snake, and we also give a direction. So we return the u.body composed with the new direction, and that's it, I guess. So for example, if you were to do snake f dot orient, and we pass it the new direction, which is going to be 0, 1 or -1 to make it move down. There's a problem. Okay, snake, I guess, direction. It's the wrong way around. I'm reading it the wrong way around. I guess if you give it the right hand argument, this switches. So I guess this is going to be snake now. This is going to be direction. Didn't really know that. Good to know. So this should work. Oh, no, wait. With direction. Okay, maybe -1 is going up. Yeah, we want it to go down. Yeah, so it's going down. Yeah. Okay. We want to have some control over this, so let's create an input class. Import class again. We want to read some inputs again, so key dot is down, I think. Ray-lib key is pressed or is down. Is pressed is, I think, the one which only triggers once. Pressed. Key dots left. Then orient, or yeah, we pass in the snake and we return a new snake. So snake goes through this again. Interesting. We want to edit the snake if that's the case. So I guess you want to write it like this. So if this is the case, then snake updates to with snake f dot orient in the direction of left, which is -1, 0. And otherwise do nothing. That's for these other directions as well. Orient right, which is going to be 1. Orient, or let's do, because this you can define in very different ways. Let's just do clockwise rotation. So let's start with right, then go to down. Down is 0 on the x-axis and 1 on the y-axis. Then we go to left indeed, and then we go up. Up is 1. No, 0 on the x-axis and up is -1 on the y-axis, because you start on the top left. The top left. And you go whoop, whoop. Okay. Okay, so we're changing the orientation when needed. We need to call this in the beginning. Inputs with snake. Oh, actually, we update snake with input. And here in the end, we return snake, which could be modified or not. Oh, it's doing something. It's updating still in, because of course I'm orienting it constantly here. Yeah, interesting, it's a square. I guess the spacing between the positions I'm not taking into account. So they're all just a tiny bit offset from each other. Let's change that. So when we draw, let's also give this some space. And let's actually use the unpacked version here. Unpack snake. And we grab the u.body. Okay, so we're going over the body parts. This is the size, which is scaled up, but we also want to scale up this by, I guess, the node. Let's make the shorter version of these. So P and W. We just need to look out that we don't override these with other things. P and W. So P dot node size and W dot scale. We scale this with P dots node size, I guess with the same things. W dot scale. Let's see if that works. Well, yeah, it does. Another thing about Snake is that it moves quite slowly in steps. So we want to have some type of clock. Only the problem is if you freeze the whole game each time, then you don't get any input in between frames. So there is a very cool new function in that Ray-lib, which is a clock in the BQN implementation. You can start it with start clock. That's here. And then you just get some, if you do call the tick function, everything updates, and you can get some cool time management. So I'm going to use two clocks. One is the main clock, which is a start clock. Start clock, and there's a game clock. The main clock is just going every frame. Main clock dot tick. So it's going to tick each frame, going to count up the frame and see and also manage the past elapsed time between the last tick. We're also having the game clock, which we're gonna make depend on the main clock. So we create this new block where we have we collect the game clock frame, which is gonna stay at 0 first if you don't update it. We're gonna see if that's smaller than the main clock time multiplied by 5, and then only then everything in here runs. We need a otherwise statement. What's that? So first this is going to run instantly because this is going to be small and this is going to be bigger, or because it's on frame 0. Then what I'm going to do is count up the game clock. Make it have a tick, which means it's going to be 1, the frame. And this is gonna still move up with this tick. And when there is 1 second multiplied by 5, so that's a fifth of the second elapsed, this is gonna be bigger again than 1 frame, and this is gonna run and it's gonna tick. So each fifth of a second, this inner block is gonna run. Input we want to always do, drawing we want to always do, only moving we only want to do at this tick. So let's start that. Start clock. Oh yeah, it's in Ray-lib. Ray-lib I'm importing as R. So I need to use R. Okay, so now you can see it moves way slower. There is something weird happening with the width, the pixels, or the spacing. I guess the size. I shouldn't use node size, or maybe not this one. Oh, it's just not really thinking about it, but just changing stuff and see if it works. That's a very bad practice, but it just takes too much brain power to actually think everything through. Let's see what I did last time. That I thought it through back then. So, okay, last time I ignored node size. Don't know if that's what I want. Don't think so. It's mostly that the position is too small, so you want to scale out the position, I guess. Node size. And it's drawing outside of the screen. Or the position is too small or the scale is too big. Ah, yeah, I need to divide it by 2 because this is gonna go to the left and to the right. That's the problem. Okay, it's way simpler than I thought. Divided by 2. Yeah, then you get the actual snake. Okay, so we have a cool little snaky boy. I guess one cool simple thing we can do is make it wrap around. That's quite easy. What you want to do is if you're changing the position, moving it, then first before you want to calculate the new position, which is so the u direction plus the first pick of the u body, so that's the head of the snake, and you want to modulate it around the playground.size, yeah, which is gonna mean it's gonna wrap the x and the y. Oh, it's not doing that. Oh yeah, I need to use this value, new position. Yeah, look at that. So it's just modulating. So when it's too big, it's going to go back to 0. When it's bigger than one of these, it's going to go back to 0, the x and the y. Okay. Another thing I think which we might want to do is make some candy to eat. So let's create some candy functions. First, you're going to get the get function, which is going to be a function which returns candy, I guess, only to position. So, for example, 2, 2. But what you actually want to do is just get a random position. So let's do rand.range playground.size. Then for each of those, that will get you a position. Oh no, p.size, p playground.node size. That should work. Oh yeah, of course. If I'm calling it here, it doesn't know the context. Okay. Anyway, it most probably works. Then we'll do a draw function, which will draw our candy. I'm gonna get the candy, which is now just a position, and we will do CDOS black, so black color, draw rectangle, and this is just gonna do the same thing as the other one, which is subtract and add with a size, which is going to be the p.node size multiplied by the w.scale, again divided by 2. You can also write this like this. I feel like that's better because then you don't have to keep that in your head after the parentheses. Let's do it here as well. Okay, less parentheses is better, right? Okay, where was I? Here. And give the position, which is just going to be the candy for now. I have a point here for some reason. Okay, oh yeah, we need to do something with it. So on the start, we are creating a candy, a little candy, candy f.gets. Oh. Let's pass it in here as well. Oh. Hello, candy. Let's receive it here. Here, candy. Oh. We want to draw the candy, so what's happening here? Yeah, I guess that works. Candy, yeah, let's do the same for this one then. Because now you see it doesn't change it, it just does some side effect. Candy, f.draw candy. And that's it for now. Oh. Candy f.get. Trying to read a field from a non-namespace because I'm probably not exporting it. I am not. Okay. Expected equal shape prefix. Candy. Okay, let's see what I'm getting here. In draw. Yeah, okay. Let's remove the other show. Is there another show? No. What's happening? It's giving me and the candy position, but also this, because this is the only show there is. That's strange. Candy F, candy. Oh yeah, I'm only returning the snake, so we also return the candy. Yeah, so we have a little lovely candy, which we cannot eat, and it's a bit offset. That's strange. Okay. So everything you can do with a candy is just eat it, or all you can do with a candy is just eat it. So let's try to do that. We need to check if the head of the snake is at the position of the candy. So we can export this unpack and have some logic in here, which is going to check if the head is at this head of the snake is at the candy. So snake f.unpack snake, and from that we get the body. From that we access the first index, which is going to be the head, and we're going to see if that matches the candy. If that's the case, then I guess we're going to remove the candy, or we're going to create a new one. Candy it's overwritten by candy f dot get. No header matching argument. Oh yeah, and otherwise do nothing. Okay, so if we're at the head, this is strange. Why is it so offset? I think this snake is a bit drunk. Nope. What? Yeah. That's a strange number. Ah, okay. So the candy is positioned somewhere, but I'm not drawing it correctly because I'm not doing the multiplication on the position. What I want to do is multiply this by the real scale and p.node size. And that happens before I'm calling the fork. Yeah. Boop. Yeah, so I'm eating it and it's moved to the next position. Another thing we want is for the snake to be able to grow, of course. So we have move and we want grow, which is we're going to get the snake. What we want to do is attach pieces of a part of the tail. So we unpacking again, unpack not snake. I think this is not the most performant thing to unpack and repack it again each time. But oh well, we're just enjoying ourselves here. Okay, u.body. So we have a direction composed with u.body, but it's u.body attached or enlarged with a flipped version of u.body. So we flip it, and then we pick the first element. No. Oh yeah, u.dir. Unpack dot snake. There shouldn't be a dot here. Okay. Oh yeah, I'm not even calling it. Okay. So this is the position where where a piece of candy is eaten. What we want to do is update the snake to snake f dot grow, and that should work. Okay, is it growing? Yeah, it's growing. I think it's longer. Yeah, it's 4 now. You see how easy that is in BQN? You just type some stuff and then you get it. There you go, it's longer. I think, I hope. Boop. Yeah, it is getting longer. That isn't what she said. You shouldn't make those jokes. Okay, cool. And another essential part of Snake is self-intersection. And I think if I've done that, that's going to be the first part. Then we have the basic Snake. And then after that, we're going to do this whole graphic stuff in the next parts. Okay, so let's do some self-intersection. We're going to make a function. I feel like this should be here. Let's see, is self-intersecting, or maybe there's a better way to call it, like eat self. No, self-intersecting, I guess. Okay, which we're gonna give this Snake again, and then we're just gonna pick out. We're gonna unpack it. Unpack Snake. Let's give this some more space. Okay, we're gonna check if the body head, that's the first thing. Head, I guess we can save it, or we don't have to maybe. If the head matches any of the other body positions, and if that's true, then this should return a boolean, which is gonna give us the collision or not. Oh, this is gonna return a whole mask, and we want to see if either of them, this should be or, no, it's and. I always get them confused. Or full, so you see that either of them are true, then it's self-intersecting, and otherwise it's not self-intersecting. So this function is different because it's not going to return a snake, it's going to return a boolean. And let's use it. So, I was calling snake. Within the game frame, we're going to check a snake f dot is I guess self-intersecting question mark, self-intersecting. If that's the case, then the game is over. I guess we'll just restart it. Yeah, let's surely, I don't have much time left, but do some simple state loop, because that's, I think, an interesting aspect. State loop, with the state loop, I mean that we're going to have a state, so like I'm playing, I'm dying, or I'm starting. So the game has some control system. Let's define states as, states as an object with all the different states. One is playing and one is dying, I guess. Dying? I guess that's it. Which is two different things. We're gonna pass in a state to the game, which is gonna be states.playing. That's gonna be the start state. And we're gonna receive the state here. And we're gonna pass it in again at the end. Notice that all the modification, all these things I'm doing are all in this main game loop. I'm trying not to do it anywhere else. So all the modification control is over there, and this is all, I guess, pure functions instead of drawing, but drawing doesn't really affect any param or variable. So I guess you can call it pure, I don't know. But all these are pure functions. Okay. Yeah, so we have a state now, and we want to act differently within different states. A nice way to give some, like, not make it very messy is create functions for each state. So you have a playing state function, which is going to get called with all the standard parameters. When we're playing, and there's going to be one like this for dying. All the stuff we are doing in this one is going to be for playing, because this is our play stuff. For dying, we're going to do other stuff. what we want to do is, let's peek what I did last time. Use the lovely choose thingy, this one, which is gonna pick out our function by state with the state parameter. So state now just simply represents a number. I'm gonna bring this down so you can see it. Yeah, state represents a number. This is 0, this is 1. And we can align those to these functions we have above, which is playing and dying. Or what I did last time is, yeah, I did this. I'm going to explain that. State, snake, candy. What this is doing is it's getting in all these parameters. It's going to do the left function, which is pick the first, and the first of this array is the state. So that's going to be the number used to choose which function it's going to use. So if state is 0, it's going to call playing, and if it's state 1, it's going to call dying, and then it's passing in all these elements. And at the end, it's going to call a function, and this function is going to return this new stuff, and that's also going to return to the per frame. So that works perfectly, and this should work. Self-intersecting. Oh, I was writing this. Sorry, I think I got off track. So that should still work. But now we can also call a different state. For example, if we're self-intersecting, then state modifies to states.dying, or it was dying. States.dying. States.dying. Yeah, that should work. Otherwise, don't do anything. That would mean it's not happy. Self-intersecting. I need to pass in the snake. No. Must be a list. Default function. What am I getting back then? Let's show it. I'm getting this array. I need to match on the major cells. Yeah. Oh, no snake anymore. I guess because I'm dead instantly, because this one is 1. Because I'm matching the head with the head, and the head is always at the head. Because, yeah, okay. So I need to ignore the head, of course, which is just going to mean drop 1, which is drop the first element, which is the head. So now if I play, everything just works normally. Oh, what happened? I don't know. Okay, let's play it calmly. We're playing, everything works normally, the snake is growing, but when I self-intersect, everything is gone. And everything is gone because it goes to this other function, which is dying, and there nothing happens. So what we can do is, what I did last time is make it blink, because that's very arcadey and cool. So let's do snake functions.draw snake. I'm going to draw the snake pod on a timer. We can use the main clock. Dot, I guess, time. Let's see what I did last time. Oh yeah. So this is going to be in a block. And I'm going to see 0.1 is bigger than 0.2 modulus. That's what I did last time, which is meaning it's going to modulate around 0.2 seconds, so 0.2 seconds, and then see if that 0.2 seconds is bigger than 0.1, which means half of the time it's going to be off, half of the time it's going to be on, at an interval of 0.2 seconds. Question mark, draw snake, that should be it. And we can also draw the candy, candy function.draw candy. So, playing, it's a bit annoying that it's going on the edge of the screen. Also something I'm gonna fix. Okay, let's self-intersect. Oh, it's crashing. Oh, it's also doing stuff. Let's remove that show. Okay, Snake2 main clock, no header matched argument. I didn't do the otherwise part. Otherwise do nothing. Yeah, so let's eat this candy, delicious. Yum, yum, yum. Okay. Oh, what is happening? Oh, yeah. The small thing is that I can move in the opposite direction of what I was doing, and then it's going to self-intersect, obviously, because it's going to go over its own body. But yeah, so if I interact now or do that, then it's going to blink. And I guess what I can do as well is see if it's going to be key dot on, no, is pressed. Key dot space, I guess, is an option. Then state is going to be modified to state dot playing. Otherwise, to do anything. That would mean that if I die and I press space, I'm going to start again. Only nothing resets. Oh yeah, I can do that. The best thing to do, sorry, it's almost done. The best thing to do is to create a reset state. Where is the state? There. Reset state. It's going to be 3. We add it here. And we also create a function. And this is just gonna create all the stuff anew. So state is gonna be state.start, the playing. Snake is gonna be snake f.gets in this. And candy is gonna be candy f.get. This is going to be reset. Okay, so returning all fresh new things. And we can actually use this as well at the start. So we call this game. We don't need to pass in anything. We just keep this empty. And then we call reset. And reset is going to fill the values. And this is good to do because then you don't do it on 2 places. You keep it in 1 space. State.playing. Fill states. It should be states. States.playing. Yeah. So. Okay. And the last thing, oh yeah, so, whoop. Oh wait, I need to make this move to reset. And then, if I reset, whoop, it's gonna go back there, I guess. It was acting a bit weird. It's shooting very quickly. I guess because there is something happening with, okay, oh. Okay, sorry. The reset also needs to reset the clocks. That's the problem of main or global functions. I'm gonna make that better as well later. So game clock. There needs to be a reset function in here, I guess. Or just gonna create a new one. Hey, why not? Game clock is gonna be r.start clock. Same for main clock, and I'm going to use that here. I'm just going to make these empty. That should reset the main clock.tick. Doesn't work. Oh yeah, because it doesn't exist yet. Then only all these problems if you use global variables. State. Okay, for now I'll just do if, main clock match, doesn't match, add. then I'm going to do that. Otherwise, do nothing. That should work. But I don't think that's a good way to do it. It's better to keep it in the loop. So self-intersect, start, and then we're there again. Great, great, amazing. Okay, then the last thing I'm going to do is just fix this problem of being able to go backwards. Because that's quite a simple one, and I think it's also a cool show of the capabilities of BQN. When we're moving, or when we're doing the orient, we want to do a check. If u dot or direction isn't the opposite of the other direction, so u dot direction. So I think this is very cool. We just see if the direction doesn't match the direction multiplied by -1, or like that, because that's just the opposite of the direction. If it doesn't, if it matches the opposite, you just don't do anything. So we wrap this. You can even do that. No, you need to unpack it first. If it doesn't match it, then we give it direction and u.body. Otherwise, give it u.direction and u.body. That should work. Then you cannot go to the opposite direction again. You don't see it, but yeah, it's not allowed to do it. Okay, so that's it for now. Oh wait, large. But cool. Okay, so that's it for now. Thanks a lot for watching. It's not perfect and definitely not done because I want to make this cool, awesome game, and this doesn't look anything like it at all. But it's a bit intense to do everything in one sit, and maybe it's cool to cut it up. So this is going to be the first part, where I did all the basic groundwork, 106 lines. I can zoom it out so you can see everything at once, I guess. Everyone says it all should fit on, or it's a terse small language, but if you do all these objects and stuff, then it's gonna get big still, because I don't really use a lot of tacit here still. There's still some little tacit stuff in between. But yeah, if you're excited for the next episode of this, please let me know. Give me some feedback. Maybe the code is totally stupid and wrong. Maybe things are very unclear. I'd love to hear those things. And I'd love to continue this and make the awesome, cool version. I'm excited to make all these cool details and make it feel good. And like, for example, this stomach is full if he eats it. And all the corners and the tail and the head, it's so lovely. So yeah, that's going to be it for now. And thanks a lot for looking at this cool language. And see you in the next one. Yeah. Next one. See you in the next one.